Hello, am I audible? Hello, ma'am, கேக்குதுங்களா? Ma'am, Usha ma'am, கேக்குதுங்களா? Hello, hello, Usha ma'am, கேக்குதுங்களா? Ma'am,
Yes, sir.
கேக்குதுங்களா?
Audible,
Teamsல
sir.
கேக்குதா?
Audible, sir.
Yes. Yes, ma'am, yes, ma'am. So, am I audible, participants? One or two can respond, please.
Yes, sir. Yes, sir. Audible, sir.
Yeah, I'm sorry. I think I'll just take 5 minutes quickly to end. So far, I've been talking about when you're going to develop IoT applications, it's not that only software side, you should equally work on hardware as well. So it is the time for you all to, as a component wise, you need to develop. Am I audible? Hello? Hello?
Yes, sir. Audible, sir.
Yes, sir. So what we need to do is we need to develop a program and deploy into the hardware environment. So and we need to attach required sensors and activators, and then we need to power up the device with a battery, because that is where we whatever the constraint adaptation I have been talking to you in terms of the 6-low-pan on top of the L2 normal layer. And similarly, RPL routing protocol alone, we have to develop for routing the IoT related M2M communications. On top of that, not like HTTP heavyweight, we need to develop a co-op and MQTT. So in that context, we have a Contiki NG with Kuja. So it is a operating system. Whatever the RFC complaint, whatever I talked about, all the 3 adaptations, those adaptations we need to develop. And definitely we have a ARM processor, Cortex M3, M4, and textile instruments like MSP430 support. We have all these hardware wide setup variant supports available in this platform. I think the whatever the environment which I've explained so far, that is the Linux environment. That is where I've installed Quantic NG, and you can put even any other like a virtual machine, and you can install it in your Windows even. So I put it in the separate track in the Linux. There we need to have this much of requirements required, and I think I leave the slides to you anyway. It is this particular Quantic NG is open source. Please understand, you no need to pay. You no need to pay any licensing. It is open source. It is available in GitHub itself. So people of open-ended people, they have developed it. It is available. Lot of supports also available. Take a download from this particular GitHub link, and then we need to install some of the prerequisites like apt-get install, build essential, deoxygen, git curl, wireshark. These are the things we need to do, and then some of the configuration tools like automake, libx mu development. These are all the things we have to install. I think the one which I've the steps, these steps is taken from this particular link only. And for a ARM compiler, hope you know, like a C, we should have C++, C compiler, C++, Turbo C++, Java C compiler, or C Sharp. Like that ARM environment, we should have a ARM compiler as well. So that is available in the tarball, and you need to download tarball and extract using tar xjf, and then we need to do the set path. Then we need to install the appropriate GCC support for MSP430, because we are going to write a program in C, and through GCC, that's Linux based support, and that is where we have to put a OM path, Java OM for this also. Similarly, we can install a co-op client using this step, and MQTT broker architecture also, that is basically from Mosquito clients. So from there we have to install. Once you all done this installations, I think these are all the prerequisite steps. Then you can clone from Quantic NG GitHub. From there you clone it, and you will be getting the entire operating system available to you in your Linux environment, in the inside a home, or downloads wherever you can keep. And once installed, it's available in your home, and you can navigate into that folder like a CD Quantic NG. Inside this, you can what you call run this command like a submodule update init recursively. So this in this initialization configuration will be done with this step. I think I have 10 different programs brought it here because of this technical glitch. I could not. I'll just wind up quickly with the 2 minutes itself, which I committed already. So you can run the program in a command prompt mode. Even through GUI, like a Kuja emulator, we can do LED program, counter design for up and down counter, because when you wanted to measure your applications like IoT context, you should have a counter also, a timer based setup. That application we have here. We have virtual sensor and null net RPL routing for between client server communication, border router, co-op, MQTT, all these protocol stack, whatever we have developed, all the components, one application, I've developed it. I will share the C code and steps alone, like uh, we have the hierarchy initially, like architecture, CPU development, various platform, like we have a Sky mode, we have a Zoll mode, Zigbee mode, like that. We have a different platforms. The test files, we have tools inside this tools only. We have a Koja and OS core files available here. The applications are available inside the example folder. I have created a one example inside example Vetri folder inside some trial run application trial.c. It's not a general C. It is a OS based C. It's not a usual C. It's a OS based C. So inside this, I think we should have another file called make file. In the this particular source code file and make file, we should have connectivity, and then make clean. There are many targets you can choose. Native means your own development board laptop itself will work as a target. That is a native machine host target, same machine. If you can dump the code into separate USB attached sky mode, means you have to run a command called make space target equal to sky. So the sky mode must be attached to your USB drive through the USB drive. Similarly, Zowl mode, Zigbee mode, whatever the program you have written, that will be reside in the program memory of that particular mode. This mode is basically already controller having a program memory area. When you attach battery and the ports are configured accordingly, and you can attach a sensor with appropriately, because inside this C program you're going to write it and accordingly counter program, or you I think in the mode separately autonomously is going to work. So to test before you deploy, you can test that in the terminal mode whether it's working all the functionalities correctly, or through GUI Kuja environment you can see through GUI also how RSSI of the node coverage and buffer view and the radio duty cycle, all these things you can able to see in the Kuja emulator. So these two files, I mean examples for whether you run with terminal mode or GUI mode. We have a LED program. I think you can write a counter application timer, appropriate time reached, the LED is going to glow. That's the event is going to be emitted, and you can call appropriate interrupt appropriately. So that particular program about this. So basically, this program and make file inside LED name you have to keep. So other procedures are same, but according to the application, you can test their functionality. So the code what you have written inside a C, that is having appropriate functionalities. Like we have a counter design, we have done virtual sensor, done null net, RPL routing, which I said already. Routing means it's a discovering path between source to destination, because the intermediate node will work as a route like a forwarding node. So how this will really works as a RPL routing for message communication between after establishing route through route request and route reply. So this we have done it in the Zolatia mode. I think I could not run Linux environment. That's the reason I'm just telling you overall view, border router, gateway border router, and finally we have done a co-op also. What I mean is, not like HTTP. You should run inside a browser. I think all these things I want up time another constraint, because this technical glitch is another constraint. Like HTTP:// you run no same way in the mode. This is IPv6. One of the mode in the host. You can configure that mode, maybe a temperature sensor. That value it will really will display. I think I thought to run and ask you to run, because in the browser only you have to add add on with the co-op installer. That 2 seconds, not 2 seconds, 2 minutes it will take in your in each one of your browser to update the co-op. So instead of HTTP, you can use co-op://. This is a IPv6 address and appropriate core, and you can run the server, and you can see your the client. Although it is running in my machine, my laptop emulator environment particular sensor, the sensor value you can read from your environment. Also, you can control that sensor. So that is what is really required as one sample example through co-op. Similarly, MQTT also is there. So to explore all these things, we should have a IPv6 and 5G support, because 5G is having a greater data rate bandwidth support. We have a support towards high level bandwidth applications, because we need to have a high data rate, and we have most of the devices with AI capabilities. So this is what is IoT 5G stack for IoT applications. I think I just I'll share the sample code for those 10 applications which I have developed, small component for a part of to build a overall stack of IoT. Those things I'll share it to the coordinator. Thank you all for your attention, and your patient listening. So if you wanted to get some more help or any more details, you may note down my email ID and mobile number. You can reach me for your further queries. Thank you all for your attention. Usha ma'am.
Yes, sir. Thank you, sir. And sorry for the inconvenience created, sir. I do not know why it has been created like that.
I think initially itself, if it's Linux is not allowed, it would have told me. I don't know what is intermittent problem. I don't know.
Only because of the Linux platform, I think, because Microsoft Teams, it's proprietary of Windows version only.
No, ma'am. No. We have this proprietary. We have installed it in the Linux environment. They give Linux version also. I take classes for the MS Teams in the Linux environment also for our students.
Yes.
I don't know what is some other otherwise I think up to 255 they're all fine, I guess. After 255
yes, sir. Yes, sir. What happened was I was not able to hear your voice, so I just left the meeting, and then I was trying to join,
unable
but
to
I
join.
could not join. Yeah, sir. So all people were waiting in the lobby. Also, they were not able to join, sir. Some 19 people were waiting in the lobby. They were not able to join.
Yeah. Sometimes I also faced in Linux to join, but that's the reason for me all application closed and coming back and restarted, ma'am. So it is taken a lot of time.
It's sorry, sir. We are very sorry,
no problem.
We make sure that it will not be created in the next sessions. Yeah. I think so. We'll see. So,
I'll share these 10 files, ma'am. If they're over interested to develop module-wise for this IoT stack in the open source environment, it's free. You need not buy any software. You can share those who are interested. They can work, ma'am.
Sure, sir. I'll share with them. You please share your PPT and then details. You please let them know. They will. I'll share with them, sir. Okay, as usual. No problem. Okay. Thank you, sir. Okay.
Yes, ma'am. Thank you, ma'am.
Sir.
Thank you for that. Participants, you have any queries? I'm sorry, because of this Aribari, I forgot to ask any query or any interaction. Yeah, participants, one or two can unmute and talk, because most of you are a teaching community. It will be great if you give comments or any input or any queries. Hello, any professor? I think there are 20 to 30 professors are there. I am not joined full session. Please share its PPT. Definitely, I will do, Anupriya ma'am. Any professors? Anupriya Pathak ma'am, I will share the PPT and material, definitely. Any other participants? Taylor sir. Anbu Karasi ma'am. Taylor sir said very good session, more information. Any queries or anyone working in this domain or wireless sensor network, IoT related context? Because ultimately you have to transfer all these skills to a low powered tiny node, that is the hands up VLSI domain, and you need, before that you need relays in FPGA boards. That is what is Anpu Karsi ma'am said, no doubt. Lakshmi Bai ma'am said, thank you sir. Nice session. Any other input or any queries? Anyone wants to talk? Because it's online mode is keep going like online only. I thought one or two can unmute and talk. It will be better.
Sir, I just have one doubt.
Yes,
So whatever the programs you are going to share us now, if it's an open source, Contiki is open source tool you have told. If we use that, we can create some small platforms for our IoT applications. Sir.
Exactly, ma'am. For ultimately, they have to develop all the stack, physical layer stack, then 6-LoWPAN routing, then co-op. This is the basic interconnection of all the stack, and on top of that, any application they may run a small timer application, maybe for nuclear power plant. Temperature raises above that, it will be really indicated and automatic. Action also emitted remotely, ma'am. That is what really, even a temperature value I thought to show you. Some of you you are away from me, so anywhere in the globe the same IPv6 you can able to access the device status, device value, and then control also. That is more essential.
Oh, okay, sir.
As a proof of concept, this is any application you can put any relay and you can control any pump motor away from you, like a precision or control power plant control. Anything is possible, ma'am.
Okay, so we should work on it, I think.
Yes, ma'am. Yes, ma'am.
Yes, sir. Thank you for your very nice presentation, sir. It was really useful, and we have learned new tool for our further research study and for giving to the students community. Thank you very much, sir. And participants, can we wind up? Yes, sir. We are very sorry with the
no issues, ma'am. Yeah, thank you for the opportunity to share all my technical sites to teaching community. So we are all not industry people. We are all teaching academician. I'm very happy and open-ended to share all the technical insights. Thank you all for your patient listening.
Thank you, sir. Actually, you asked for 2 sessions. I should have given to you. Then only the things would have been sorted out.
No problem. Based on, I think you have a logistic reason and constraints, so we will plan some other occasion for your students. You can plan, ma'am. We will have answer for your students also.
We will be in touch with you, sir. Thank you, sir. So I'll stop recording and I will.
Yes, ma'am. Thank you, ma'am.
Thank you, sir.